What's up guys, this video is about how a capacitor works. A capacitor in construction consists of two parallel conducting plates separated by an insulating material called a dielectric. A capacitor is a device that stores electrical energy in the form of an electric field, formed when there is an excess of electrons on one plate and a deficit of electrons on the other plate, or when one plate is negatively charged and the other plate is positively charged. This is achieved by applying a voltage source across capacitor plates. When a source of voltage like a battery is connected to an uncharged capacitor, that has an equal number of electrons and protons on each of its plates. The positive side of the battery attracts electrons from one plate, leaving the plate with a shortage of electrons. And at the same time, the negative side of the battery repels electrons, which are collected on the other plate, causing the plate to have an excess of electrons. The dielectric prevents a direct movement of excess electrons from one plate to the other plate. In this way, a capacitor is being charged. A capacitor is used to power electrical components, usually for a short period of time because of its low energy storage capabilities. It is usually used with other energy sources, where it is first charged and then discharged through the load when the voltage source is powered off or runs out of energy. The animations in this video follow electron flow. Electron flow is the actual direction of current, which is from negative to positive. There is another current called conventional current, which was believed to be the direction of current before the discovery of electrons. Conventional current flows from positive to negative. The amount of electric charge a capacitor can store is determined by its capacitance. Capacitance is measured in farads. The capacitance of a capacitor tells us how much electric charge a capacitor can store when connected to a particular source of voltage. If the capacitance of a capacitor and the voltage it is connected to are known, the amount of electric charge that can be stored by a capacitor is given by the product of capacitance and voltage. For example, if a 470 microfarad capacitor is connected to a 12-volt battery, the amount of charge that can be stored by a capacitor is found by multiplying 470 microfarads by 12 volts. We get 5.64 millicoulombs. Electric charge stored by a capacitor is measured in coulombs. To understand how big 1 coulomb is, 1 coulomb is equal to 6.24 quintillion electrons, which is also equal to 1 ampere. There are three factors that affect the capacitance of a capacitor, which are the type of dielectric material, the distance between plates, and the cross-sectional area of the plates. Cross-sectional area of plates. Larger plates provide a greater space to store electric charge. As plate area increases, capacitance also increases. The cross-sectional area of capacitor's plates can be effectively increased by rolling capacitor plates into several rows. Distance between plates or dielectric thickness. Capacitance of a capacitor increases as the distance between plates decreases. This is because, as the distance between plates decreases, the opposite formation of electric field is reduced, and capacitance is directly proportional to the strength of the field between the plates. The field is stronger when the plates are closer. Dielectric material. Dielectric provides an easy establishment of an electric field, while preventing excess electrons from directly moving from one plate to the other plate. There are various materials used as dielectrics, such as paper, mica, and more. The capacitance of a capacitor depends on the dielectric material used. Materials for dielectrics are rated based on the ease with which an electric field can be established through them, called permittivity. The larger the permittivity value, the larger the capacitance is. To get the actual capacitance of a capacitor, we combine the three factors in the formula. Capacitance is equal to the product of absolute permittivity and cross-sectional area, divided by distance between plates. Capacitors are grouped into polarized and non-polarized capacitors. Polarized capacitors are used in DC circuits only. They are characterized by stripes with positive and negative signs, which indicate the negative side and the positive side of the capacitor, while non-polarized capacitors are used in both DC and AC circuits. Capacitors can be either fixed or variable. Fixed capacitors have a specific capacitance value, whereas variable capacitors have a capacitance value that can be adjusted between their minimum and maximum values. Variable capacitors consist of one or more pairs of plates. Each pair of plates is one fixed plate and one movable plate. The capacitance value is adjusted by moving the movable plate, and the overlap between the plates' cross-sectional areas determines the capacitance value. When selecting a capacitor for a particular circuit, there are several factors considered so that the capacitor will operate as required. These factors include voltage rating, capacitance, tolerance, and frequency if it is used in an AC circuit. The voltage, capacitance, tolerance, and frequency rating of a capacitor are usually printed on its surface. A capacitor should be connected to a voltage supply that corresponds to its voltage rating. As higher voltages than its rating damage the capacitor. Tolerance is the amount by which the capacitance of a capacitor varies from its stated value. It is important to use a capacitor with a tolerance value that suits a circuit, so that the circuit delivers the desired results. The capacitance of a capacitor is crucial in determining the amount of charges it stores, ensuring it provides enough power for a circuit's needs. Let's look at what happens when you connect a capacitor to DC and AC circuits. In an AC circuit, electrons change direction of flow. When a capacitor is connected to an AC circuit, it charges and discharges as the current changes direction. In this way, we say a capacitor allows AC current. When a capacitor is connected to a DC circuit, current flows while a capacitor is charging. When a capacitor is fully charged, current stops flowing. This is because in direct current, electrons flow in only one direction. In this way, we say a capacitor blocks DC current. The total blockage or opposition given to the flow of current by a capacitor is called capacitive reactance. Capacitive reactance is measured in ohms. Capacitive reactance is equal to 1 divided by the product of 2 pi, frequency and capacitance. For example, in the previous AC circuit, the capacitor had a capacitance of 470 microfarads and the frequency of the circuit was 50 Hz. By putting the values of frequency and capacitance in the formula, we find that the total opposition given to the circuit by a capacitor was 6.77 ohms. Okay guys, that is it for this video. I hope you find it helpful. Catch you in the next videos.